Part C.3, examples for multi-level caches. In this part, we will do two examples. These two examples, relatively simple. Yeah, just use the formula we derived from the previous video, but there is some, relationship, something you could, easily get confused. So I want to compare that part, point the confusion part to you. Yeah. All right, so let's start the first example. Example number 16. In 1,000 memory references. Yeah. So you know the meaning of memory references, right? Yeah. 40 misses in the first level cache, 20 misses in the second level cache. The L2 cache miss penalty is 200 clock cycles. All right, so look at this. The total number of memory references. We know there are two parts in the memory references, right? Instruction access and data accesses, two parts. Total, putting together, you have 1,000 memory references. Then, first level misses only 40. So pretty small number, 40 first level cache miss. After that, the second level, 20. Yeah, so that's the given numbers. Yeah, miss penalty. Yeah. That head time, L1 head time 1 clock cycle, L2 head time 10 clock cycles. The question. Excuse me. The question. What is the average memory access time? Yeah. This one, we can apply our formula directly. Yeah. Yeah. So let's look at the formula. Yeah. So we derived this formula from the previous video. Yeah. If we compare with the conditions in the example number 16, so you can see many numbers are known in the formula. Which one is known? L1 head time is known, given. L2 head time is given. P2 penalty number also given. But we need to calculate R1 and R2. R1 formula, R2 formula, two local miss rates. The first level cache miss rate, R1. L1 misses over L1 requests, right? Yeah. L1 misses 40 misses. L1 requests 1,000 memory references. That's the L1 requests, including both instructions, data, but here we do not separate. We do not need to separate. No. So we consider them together. That's the definition for the miss rate. So the answer is 4%. 4% L1 miss rate. Next, second level cache miss rate, R2, L2 misses 20, L2 requests. L2 requests equals L1 misses. So that's why we use 20 over 40. 0.5, you can see the L2 local miss rate. Usually, it is a much higher number. 50 comparing with 4%. Yeah. So that's very common. So L2 local miss rate usually relatively high. Yeah. Like this. Yeah. All right. And now we are ready. We apply the average memory access time. T average equals 1, T1, R1 0.04 times parenthesis T2 head time 10 plus 0.5 R2 times 200. And we get 5.4. That's the answer. Yeah. So you can see, yeah, for questions like this, so usually, what do you need to, put some time to do? Mainly these two numbers. After that, you can plug in to the original formula directly. So not very hard. Yeah. All right. So then the next example closely related to this one, but I change a little bit. Try to get your attention. Yeah, because if you do not pay attention on that part, it's very easy to get a wrong answer. Yeah. So let's look at the question. Next one. All right. Yeah. Here, yeah, just the G2 product of these two numbers, 2%. So G2 reduced. Yeah. Comparing with R1, G2 reduced. Yeah. All right. Next example. Yeah, here I modified. First modification. In 1,000 instructions. Here, it is not memory references, instructions. So in order to calculate the miss rate, you need to convert it to memory references. So that's one place people can easily get wrong. Yeah. 40 misses first level, 20 misses second level, the same as before. P2 penalty, same as before. L1 head time, L2 head time, the same as before. But there is one new things given, 1.5 memory references per instruction. This information we need to calculate the number of memory references. Okay. All right, so here we use the same formula, but when we do the calculation, we should be careful. That's the only thing I like to emphasize in this example. All right, so that instruction, we need to convert to memory references. Thus, 1.5 memory reference per instruction, this gives us the number, how to do the conversion. We need this number, 1.5. Yeah. All right, so now let me do the calculation. L1, local miss rate, R1, this time, when you do the conversion, 1,000 instructions, then you need to multiply 1.5 memory references per instruction to scale it to number of memory references. So then you get 2.7%. The second level cache miss rate, so this time you do not. So you do not need to do the similar things. Okay? You do not need to do the similar things. Yeah. All right. You still use that 20/40. So why is that? Because you use the definition. R2, the number of L2 requests. How many requests? L1 misses, the same as L2 requests, right? L1 misses, that's 40. Denominator for the R2. Then L2 misses. So the same way you calculate, in our previous example. So you get 50%. So then the average memory access time. So you plug in new numbers. So here only this part is new. The remaining the same. Yeah. So you get a smaller average memory access time, 3.97. Okay, yeah. So Next time when you solve a question of this type, when you read the question, be careful on the information of these two places. All right, so let me finish our C.3 video here.